The night shift at Buchanan's forge ran skeleton crew. 3 men, maybe 4 on a good week. February 1897, somewhere past midnight, cold enough that breath hung visible in the lamplight. The main forge had been banked hours ago, coals buried deep under ash, radiating just enough warmth to keep the worst of the frost off the tools. Thomas Ridley was walking the floor with his oil can, checking bearings on the trip hammers, when he stopped mid-step. There was a sound. Faint, metallic. A tap, almost delicate, like someone testing a chisel against an anvil 2 rooms over. He turned his head, listening. The forge at night had its own language, the tick of cooling iron, the occasional pop of settling brickwork, the whisper of draft through the bellows. But this was different. Another tap, clearer this time. Ridley set down his can and moved toward the east wall, where the big Nasmyth-style power hammer stood in shadow. The machine loomed 12 feet tall, its frame bolted to oak beams sunk deep into the factory floor. In daylight, it was a monster, capable of shaping white-hot blooms with blows that rattled windows 3 streets away. Now, in the flicker of a single lantern, it looked like something from a cathedral, silent, immobile. Except it wasn't. Ridley stopped 10 feet away. The hammer's massive head, a block of forged steel weighing close to 800 pounds, hung suspended from its spring arm, the heavy coil of metal that gave the machine its controlled violence. And as Ridley watched, the head moved. Not much, a 1/4 inch, maybe less. A slow, almost imperceptible descent, followed by a faint mechanical click as the piston rod shifted in its cylinder. Then stillness. He called out. His voice echoed off the brick. "Mackie, Mackie, get over here." Footsteps quick and uncertain. Another worker appeared, carrying a tin of grease and a rag. He looked at Ridley, then at the hammer. "What's wrong?" "Watch it." They stood together in the cold, breath-clouding, eyes fixed on the machine. For 30 seconds, nothing. Then movement. The head dropped again, just a fraction, and the frame shuddered, not violently, almost gently, like something waking from sleep. Mackie stepped back. "The belts," he said. "Must be tension in there." "Belts are off," Ridley said. "Nothing's running." They both looked up. The leather drive belt hung slack on its pulley 3 stories overhead, connected to the dead line shaft. No motion, no power. The forge itself was cold, the boiler down the hall barely ticking over to keep the pipes from freezing. But the hammer moved again. This time they heard it. A low groan from somewhere deep in the frame, metal on metal, and the faintest vibration beneath their boots. The head descended another inch, then stopped. The spring arm flexed, compressed by some invisible force, and held. Ridley backed toward the door. "Get Brennan," he said. "Now." The machine had arrived at Buchanan's in 1889, second-hand from a Pittsburgh rolling mill that had gone under during the panic. Spring hammers were cheaper than steam-driven Nasmyth originals, and Buchanan's had been running on tight margins for years. The installation had been rushed, foundation timbers laid in a week, the frame bolted down with minimal surveying, the piston and spring arm connected to a rebuilt cylinder salvaged from a locomotive scrap yard. It worked. That was what mattered. The spring arm was the heart of the design. 15 feet of laminated steel, forged in layers and tempered to flex under load without breaking. When the machine fired, compressed air drove the piston downward, pulling the spring arm with it. The hammer head struck, and the spring recoiled, lifting the head back to rest. It was elegant in its brutality, a controlled explosion of force, delivered with precision. But elegance required balance. The spring had to be seated perfectly, the frame aligned to a tolerance measured in fractions of an inch. Any deviation, any twist in the mounting, and the system developed stress points, places where energy pooled instead of dissipating. Buchanan's installation had cut corners. The foundation beams were oak, not iron. The bolts holding the frame to the floor had been hand-tightened, not torqued to spec. And the spring arm itself, someone had noticed years back that it sat slightly cocked, not enough to stop operation, just enough to feel wrong. One of the day crew had mentioned it to the foreman in '94. Said the hammer felt tense, even when idle, like the spring was holding a breath. The foreman had checked the piston, found no obvious fault, and moved on. There were quotas to meet. The hammer kept working, and that was enough. Now, 3 years later, that tension had found a voice. By the third night, the entire crew knew. Word spread fast in a place like Buchanan's. Rumors traveled through the factory faster than steam through a boiler. The hammer moved. Not when you were looking, some said. Only in the periphery, when shadows played tricks. But Thomas Ridley wasn't prone to stories. He'd worked metal for 20 years, knew the difference between imagination and reality, and what he saw was real. The movements grew bolder, no longer just a faint drop of the head, but full cycles, slow, deliberate, as if the machine were testing its own weight. The spring arm would compress, the piston rod would slide a few inches into its cylinder, and the hammer head would descend with a low, resonant hum that vibrated through the floorboards. Then it would stop, hold, and slowly rise again. At first, the cycles were irregular, minutes apart, sometimes longer, but by the end of the week, they had developed rhythm, a pulse. Every 40 seconds, like clockwork, the hammer would move, compress, drop, rise, accompanied by a deep metallic vibration that made tools rattle on their hooks. The workers started avoiding the east wall. No one wanted to stand near it. The machine had become something other than itself, a presence, unpredictable and wrong. One man swore he felt the floor tremble even when the hammer was still, as if something beneath the boards was listening. The rumors started slow, then accelerated. Ghosts, some said. A man had died in the Pittsburgh mill where the hammer had been built, crushed between the anvil and the head during a misfire. Others said sabotage, anarchists, labor agitators, someone with a grudge against Buchanan himself. A few workers, the older ones who remembered the installation, whispered about something else. The spring arm, the way it had always felt wrong, the way the machine seemed to remember things. At night, alone in the forge, you could hear it breathing. The foreman saw it on a Tuesday morning. James Brennan had been at Buchanan's for 15 years, long enough to know that machines didn't move on their own. He'd seen boilers explode, flywheels shear their shafts, belt drives rip themselves apart at full speed. Mechanical failure was loud and obvious. This was neither. He'd come in early before the day shift to check the drive system. The leather belts were intact. The line shaft overhead was motionless. The steam supply to the cylinder was shut at the valve, and the pressure gauge read 0. Everything was as it should be. Then the hammer struck. Not a full blow, nothing that would shape metal, but enough to make the anvil ring like a bell. The head dropped 8 inches in a single, smooth motion, hit the anvil with a crack that echoed through the empty forge, and rebounded. The spring arm flexed, the frame shuddered, and the entire machine seemed to settle back into stillness. Brennan stood frozen, wrench in hand, staring. He counted to 30. The hammer moved again. Same motion, same sound. The floor beneath his boots vibrated in sympathy, a low-frequency hum that traveled up through his legs and into his chest. He evacuated the building. By noon, 3 mechanics from the city had arrived with toolboxes and skepticism. They pulled the belts, disconnected the steam line, drained the cylinder, removed the piston rod entirely and laid it on the floor. The spring arm remained under tension, compressed slightly against its housing, but with no piston to drive it, the hammer should have been inert. It moved anyway. A slow, grinding descent, metal groaning against metal, the head dropping 4 inches before catching on something invisible. The mechanics stepped back. One of them, a man named Howell who'd worked on Corliss engines and understood pressure systems, shook his head. "That's not possible," he said. The local paper got wind of it by Friday. The headline read, "The Haunted Hammer of Buchanan's Forge." The article was brief, sensational, and entirely unhelpful. It mentioned workers fleeing in terror, strange sounds in the night, and the possibility of spectral interference. Buchanan himself refused to comment, but the damage was done. Orders slowed. customers started asking questions. The hammer had become a liability. The truth, when it finally emerged, was more unsettling than any ghost story. It started with the mill. 300 yards south of Buchanan's, across a narrow alley and through two brick walls, stood Carlisle's flour mill. It had been there longer than the forge, built in the 1860s with a water wheel that had since been replaced by a steam turbine. The mill ran day and night, grinding grain with a rhythmic, pulsing motion that shook its own foundation and sent vibrations radiating outward through the ground. Harmonic resonance. The technical term meant little to most workers, but the principle was simple. A repeated vibration, traveling through earth and stone, could build energy in anything tuned to the same frequency. Buchanan's forge sat on the same bedrock as Carlisle's mill. The foundation timbers beneath the hammer were oak, porous and flexible. They conducted vibration like a drumhead. The spring arm was acting as a receiver. 15 feet of laminated steel, pre-tensioned and locked under compression, vibrating at a frequency just fractionally below the mill's grinding cycle. Every pulse from the mill fed energy into the spring. The arm absorbed it, stored it, and when enough had accumulated, released it in a slow, mechanical twitch. But that was only part of the equation. The cylinder, even drained of steam, wasn't empty. Air remained inside, ordinary atmospheric pressure, trapped behind the piston seals. As the spring arm compressed, it pushed against that air, creating tiny pressure pockets that resisted motion. When the vibration built enough force to overcome that resistance, the air gave way all at once, and the piston jerked forward. The hammer dropped. Then there was the thermal factor. The forge was cold at night, but the cylinder retained heat from the day's work. As it cooled, the metal contracted, fractions of an inch, but enough to pull the piston rod inward, tugging the spring arm down with it. And finally, the spring itself. The installation had been flawed from the beginning. The arm sat cocked, misaligned by less than a degree. That tiny deviation created uneven stress distribution across the laminated layers. Over 8 years, the steel had developed memory, a tendency to flex in one direction more than others. The spring wasn't just responding to vibration. It was guiding it, amplifying it, turning the hammer into a massive mechanical pendulum. The machine wasn't haunted, it was resonating. Every 40 seconds, the mill sent a pulse. The spring collected it. The air pressure gave way. The thermal contraction pulled, and the hammer moved, acting out a slow, self-perpetuating cycle that mimicked deliberate action. No one was controlling it, but it wasn't random either. It was physics, playing itself out through tons of forged steel and wood and trapped air, following rules that no one had anticipated. The hammer was obeying its own logic. It happened on March 14th, just after 10 in the evening. Ridley was on watch again. The forge had been shut down for 3 days while engineers debated solutions. Brennan had wanted to dismantle the hammer entirely, but Buchanan refused. The machine was worth more than half the shop's equipment combined. They needed it operational, not scrapped. So Ridley sat in the cold, lantern at his side, watching the hammer the way you'd watch a dangerous animal. It had been quiet for an hour. No movement. The mill had shut down early for repairs, and without its rhythmic grinding, the vibrations had ceased. Then Carlisle's turbine restarted. The sound was distant, muffled by brick and distance, but unmistakable. A low, thrumming pulse that rose in pitch as the turbine came up to speed. Ridley felt it through his boots before he heard it, a vibration in the floor, faint at first, then growing stronger. The hammer responded immediately. The spring arm compressed, fast and hard, driven by a wave of accumulated resonance that had been building in the bedrock since the mill went dark. The piston rod slammed forward, and the hammer head dropped in a full, violent stroke that hit the anvil with a sound like a cannon shot. Tools flew off their racks. The lantern tipped, spilling oil. Ridley threw himself sideways as a wrench sailed past his head and embedded itself in the wooden wall behind him. The hammer didn't stop. It struck again, and again. each blow faster than the last, the spring arm cycling like it was under full steam, except there was no steam, no power, nothing but resonance and stored tension feeding back on itself in a runaway loop. The frame began to shake, bolts rattling in their holes, and cracks appeared in the oak beams beneath. The entire building was screaming. Ridley crawled toward the door, deafened by the noise, feeling the floor buckle under his hands. Somewhere behind him, a beam snapped. The spring arm, compressed beyond its design limit, groaned like a living thing. For one terrible moment, he thought the whole machine was going to tear itself apart, explode in a spray of steel fragments and shrapnel that would cut through brick like paper. Then it stopped. The mill turbine stuttered, dropped out of sync, and the vibration wave collapsed. The spring arm released, the hammerhead rose slowly back to rest, and the forge fell silent except for the sound of settling debris. Ridley lay on the floor, gasping, staring at the machine. A thin crack ran the length of the spring arm, visible even in the dim light. The hammer had nearly killed him. The engineers came at dawn. Not local mechanics this time, but specialists from Philadelphia. Men who understood structures and vibration, who'd built bridges and studied the failures that brought them down. They examined the foundation first, pulled up floorboards and exposed the oak timbers beneath. The wood was ancient, warped, riddled with microfractures from years of abuse. Worse, the timbers weren't isolated. They connected directly to the building's main support beams, which extended under the wall and into the alley, where they met the foundation of Carlisle's mill. The two buildings were linked. Every vibration from the mill traveled directly into Buchanan's floor. Next, they inspected the spring arm. The crack was deeper than it looked, a spiral fracture that ran through 3 of the laminated layers. The steel had been flexing unevenly for years, stressed by misalignment, and the recent violent cycles had pushed it to the breaking point. Another few strokes, and it would have shattered completely. The cylinder was next. They disassembled the piston housing and found scoring on the inner walls, grooves worn by metal dust and imperfect seals. Air had been leaking past the piston, creating unpredictable pressure differentials that amplified the hammer's motion. The seals themselves were original, 8 years old, compressed and brittle. Finally, they traced the frame alignment, used surveying instruments to measure angles, and found what the original installers had missed. The hammer sat 3 degrees off true. Not much, but enough. The spring arm was pulling against its own housing, the frame was torquing under load, and every vibration from the mill exploited those weaknesses. The solution was expensive. Isolate the foundation. Replace the timbers with iron girders set on rubber pads. Rebuild the spring arm with proper alignment. Reseal the cylinder. Install dampeners to absorb external vibration. It took 2 months. The hammer didn't move again until June, and when it did, it was under steam, controlled, obeying the will of the operator. But the workers remembered. They remembered the nights it moved on its own, the sound of it breathing in the dark, the moment it nearly tore itself and the building apart. Some of them refused to stand near it, even after the repairs. They'd seen what it was capable of. They'd felt the floor shake beneath them and watched a machine become something other than the sum of its parts. The engineers had explained the causes: vibration, resonance, thermal contraction, pressure differentials, all true, all correct. But explanations didn't erase the memory of that sound, the groan of stressed metal, the rhythmic pulse of a hammer swinging by itself in an empty forge. Some knowledge, once gained, couldn't be forgotten. The industrial age built machines that dwarfed human scale. Power hammers, steam engines, rolling mills, mechanisms capable of reshaping steel and stone with forces that could crush a man without noticing. We think of them as simple tools, extensions of human will, levers and pistons, nothing more. But the hammer at Buchanan's forge proved something else. These machines existed at the edge of our understanding. They operated according to principles we'd barely begun to formalize: thermodynamics, resonance, material stress. We could build them, run them, profit from them, but we couldn't always predict them. A spring arm wasn't just a spring. It was a system, steel under tension, connected to wood and air and earth, subject to vibrations we couldn't see and thermal shifts we couldn't measure. Add time, years of operation, flexing, settling, and the system developed behaviors, not consciousness, not intent, but something that looked disturbingly similar. The workers at Buchanan's didn't need engineers to tell them the hammer was dangerous. They felt it in their bones, in the way the floor hummed beneath them, in the wrongness of a machine that moved without command. Their fear wasn't ignorance, it was recognition. They understood, better than the engineers, that a machine powerful enough to shape steel was powerful enough to destroy. That cutting corners, misaligned frames, salvaged cylinders, rushed installations, had consequences that might not appear for years. That the forge, running day and night, shaking its foundation, heating and cooling, was a living system where cause and effect were separated by miles of ground and years of accumulated strain. The hammer didn't swing by itself because it was haunted. It swung because we'd built it wrong, placed it wrong, and failed to understand that turned off didn't mean safe. The engineers fixed it, isolated the vibrations, rebuilt the spring, realigned the frame, made it predictable again, but the lesson remained. In the age of steam and steel, when men built machines larger than themselves, there were always moments, late at night, in the cold, when the fires were banked and the belts were still, when those machines reminded us that they operated according to rules we'd only begun to learn. The hammer at Buchanan's forge was one of thousands. How many others, in shops and mills and factories across the industrial world, were accumulating stress, absorbing vibrations, developing their own slow, mechanical logic? How many were waiting, in the dark, for the right frequency to make them move? We built the machines that built the modern world. But sometimes, just sometimes, they taught us that power and understanding were not the same thing. And that the most dangerous moment wasn't when a machine broke down. It was when it started working in ways we never intended.